Today, we're diving into one of the most powerful and, let's be honest, sometimes one of the most frustrating parts of AWS, Identity and Access Management, or IAM. We're going to map out the solutions to the most common headaches you're likely to run into. You know that feeling, right? Staring at an access denied error for the 10th time, feeling completely stuck. It's like you're in a giant invisible maze and every turn you take just leads to another wall. Trust me, we've all been there.
But what if you had a map, a guide that showed you the common pitfalls and the clear paths through? Well, that's exactly what this is. We're going to give you a clear, straightforward guide to navigate that IAM maze and get you where you need to go.
So, here's our game plan for today. We're going to start with credentials, then we'll decode those access denied messages by digging into policies. After that, we'll look at how services talk to each other using roles, and we'll wrap it all up with a conclusion that gives you your own troubleshooting map.
All right, first up, credentials. Think of this as the very first gate you have to get through in the maze. If you don't get this part right, nothing else really matters. It's absolutely fundamental.
So let's kick off with a classic. And yeah, a totally hard-stopping problem. You're setting up the AWS command line or maybe an application SDK, and you have that sinking feeling. You've lost your secret access key. Now what? Okay, before we solve it, let's be super clear on what we're dealing with. An access key pair has two pieces. There's the access key ID. That's kind of like your username. It's not a secret. But then there's the secret access key. The name says it all. It's a secret. Just like a password, AWS only shows it to you one time, when you first create it. After that, it's gone.
So here's the bottom line, and it's a big one. You can't get a lost secret key back. There's no forgot my secret key link to click. The only thing you can do, the only right thing to do, is log into the console, find that old key pair, delete it, and generate a brand new one. That's it.
And this whole situation really drives home a super important security practice. When you're setting up a new user, you've got to follow this workflow. First, create the user with a temporary password, but, and this is key, with 0 permissions. Then send them their login details through separate, secure channels. Username in an email, password in a secure chat. Wait for them to actually sign in and change their password. It's only after they've done that you should go in and add the permissions they need and turn on multi-factor authentication. All right, let's get to the real heart of the maze, policies. This is where the magic happens, and it's where most of those access-denied errors are born. Understanding how these rules work is everything.
This message, our old friend, we've all seen it. It's the reason for so much frustration. And while it looks straightforward, the why behind it can be really sneaky. So let's break down the logic.
You see, in the world of IAM, there are basically two ways AWS can say no. The default is what's called an implicit deny. That just means if there's no policy anywhere that says allow, then you can't do it. Simple. But the explicit deny is the big boss. If any policy attached to you has a statement that says effect deny for that action, it's game over. An explicit deny always wins, even if another policy says allow.
Now, here's a little gremlin that can drive you absolutely crazy. Sometimes you're sure you fixed a policy, but you still get an error. What gives? Well, it's probably eventual consistency. See, IAM is a massive global service. When you make a change, it takes a little bit of time for that change to spread everywhere. So, honestly, if you've just updated a policy, the best first step is to just take a deep breath, wait 30 seconds, and try again. It might save you an hour of pulling your hair out.
Okay, let's look at a really specific error, one that throws people for a total loop. You're an admin, you're trying to fix a multi-factor authentication device for a user, and you get this, an explicit deny on deleting the old device. You check every policy you can find, and there's no deny statement anywhere. So, what is going on? It turns out the problem isn't in your policy at all. It's a ghost resource. What probably happened is that someone started to set up a new virtual MFA device for that user, but then they canceled the process halfway through. This leaves behind an orphaned, unassigned MFA device just floating in IAM, and you can't add a new device until that old ghost is gone.
And here's the kicker. You can't fix this in the AWS console. An administrator has to roll up their sleeves and open the command line interface. First, you'll run a command to list all the virtual MFA devices in the account. Then, you find the ARN, the unique ID for that unassigned device, and finally, you run the command to delete it. And just like that, the ghost is busted. Problem solved.
Okay, let's switch gears and move on to our next section,
Roles. So, if users are people trying to find their way through the maze, you can think of roles as what AWS services use to navigate. You know, for when your EC2 instance needs to get through the maze to talk to an S3 bucket.
So here's a super common problem. You, or maybe a service you're building, tries to assume a role, basically to temporarily borrow its permissions, and access denied? When that happens, where do you even begin to look?
Don't worry, here's your checklist. Run through these every time. First, the simple stuff. Did you spell the role name right? Remember, it's case sensitive. Next, check your own user permissions. Does your policy actually allow you to perform the STS assume role action? Then, and this is the big one, you have to check the role's trust policy. This is the document that says who is allowed to assume it. Is your user or your account listed as a trusted principal? And finally, check that trust policy for any conditions, like an IP address restriction that you might not be meeting.
And here's another role-related error that trips people up all the time, especially when you're launching something like an EC2 instance, the IAM pass role error. This one can feel a little weird and abstract, so let's make it really clear what's happening here. Okay, think of it this way. IAM pass role isn't about you being able to use a role's permissions. It's about you having permission to give that role to an AWS service. It's like you're passing the keys to the car over to the EC2 instance so it can drive. This is a really important security control because it stops a user from giving a service more permissions than they themselves are supposed to have.
Whew. Okay, we have covered a ton of ground. We've talked credentials, we've untangled policies, we've figured out roles. Now, let's bring it all together and build that map we promised, so you can walk away from this ready to tackle these issues with confidence.
Here it is, your troubleshooting map. First, with credentials, always follow that secure workflow. When you hit an access denied wall, your very first question should be, is this an explicit deny or an implicit one? For roles, remember, it's a two-way street. You have to check both your user policy and the role's trust policy. And please read the full error message. It's not just noise. It often contains the biggest clues for solving the puzzle.
And look, for those times when you are just completely stumped, your absolute best friend is a tool called AWS CloudTrail. It logs every single API call made in your account. You can see who made a call, when they made it, and often the precise reason it was denied. It is the ultimate diagnostic tool for the really tough cases. Look, the IAM maze is definitely complex, but it is not impossible to navigate. Once you have this map and you really understand these core ideas, you've got everything you need to solve pretty much any permission puzzle that AWS throws at you.